Okay, to find the product, start by multiplying the whole numbers. Remember to state the unit in your product. So turn to your neighbor and talk about what this would equal and what this one would equal. So I had 4, which are going to ones, right? Times 30. So how would that look? How many tens did I end up with? 12. I ended up with 12 tens, right? What if I took 4 times 3 tens? What would I end up with?
You would end up with 1.2 tens. I mean, 1.2.
1.2.
You would get 120.
We'll start with your whole number. So we know 4 times 3. What's 4 times 3? Everybody. 12. And then just bring this down. 12 what? 10. Does 12 tens look the same as this? So 4 times 30, what is that answer? 120. So on your place value charts, I want you to write 4 tens times 3 tens. And I want you to solve that one with your neighbor. So how did you use the previous problem to help you solve 4 tens times 3 tens? Remember when we said 4 times 3 tens? How did knowing how to do that problem help you just now solve this one?
Because even if the numbers are changed around, it's still going to be the same.
Okay, even if they're changed around, they're going to be the same answer? Ooh, you kind of hit on one of our concepts we're going to talk about today.
If you took away the 0 on 30, it's the same answer.
Okay, if you took away the 0. So in this case, if it says 4 tens, what number is going in the tens place? Times 3 tens. Where is that going? In the tens. What's 4 times 3? 12. Does that work? I don't know. Just want to figure out a different way to do it? What did you say?
Well, I don't know how they did it, but I went, because I know 4 times 3 is 12, but since it's 4 tens, so you're just adding a 0.
Okay, can you start that again? Sorry.
I did, because I know 4 times 3 is 12, and we're doing 4 tens, so it's like, kind of like 40 times 30. So you just do 4 times 3 equals 12, and what I did is I added 2 zeros, because there's 2 zeros in all in the question. So I got 1,000.
So you did 4 times 3 is 12, and then you knew that since there's 2 zeros, that, do you see what happened? When you move, every time you move a digit over to the left, it goes up by how many? 10. Because this is remember, a story of units, and our unit that we're working on is 10. How everything relates to the number 10. So let's try this one. 4 tens Is that true? 4 tens is the same as 4 times 10. Give me a thumbs up if that's true. Give me a thumbs down if it's not. 4 tens is the same as 4 times 10. Are you sure if you can tell me what 4 tens looks like? What does 4 tens look like? Okay, but we can't just leave the number by itself, so what do we have to put with it? Okay, and what is 4 times 10, everybody? 40. So 4 tens is the same as 4 times 10. So raise your hand if you can tell me what 3 hundreds is the same as. 3 times what? 3 times 100? Let's see if you're right. So I have 300s. Is 3 times 100 300? Yep, stay with me, people, because it is going to build here in a minute. That's why I'm just kind of reading the lesson to you today, because it's a little complicated today, so that's why you need to pay close attention. So another way to write our problem would be 4 times 10 times 3 times 100, or 3 times 100 times 4 times 10. Are those two expressions equivalent? Why or why not? Turn and talk to your partner as to why or why not. So, are these equivalent or equal? Raise your hand if you can tell me yes or no and explain.
No, because 3 times 100 would be 300, so we put 3 in the 100 place. And then 4 times 10 would be 40, and 4 10. And then that would be, we add
So let's see, let's look at this a minute. Because we're no longer doing the one step. We have to look at it this way now, because we have this sign right here between the two. So what would that be? What do you think? 300 times 40. So we have 3 times 4 is 12. And then how many zeros do we have? 12 times 1 is, how many zeros do we have? Are they equal? Let's try another one. Have you work through this one with your partner? Okay, look at 60 times 5. What is another way to write the number 60? What's another way to write the number 60? Okay, another way to write it is 6 times 10. We could also say that the 60 is in the tens place, right? We have 6 tens. So we could take our two numbers, 6 and 5. We could say 6 times 5 times 10 because the 6 is in the tens place. I want you to solve those two problems with your partners and see if they are equal. Okay, raise your hand if you can tell me what you and your partner discussed.
We discussed how they were the same, but how they were different.
Okay, so are they the same?
Yeah.
How so?
Because they're just extracted, like pulling away from each other, but it's just done a different way.
So 6 times 10 is 60 times 5. 6 times 5 is 30, and then you have the 0, which would make it 300. 6 times 5 is 30. 30 times 10 is? What's 60 times 5? When you rearrange the numbers in a problem, they call that the commutative property. But when you're taking the numbers and grouping them differently, did we start with 6 times 10 at the beginning? 60 times 5. Did we say write down 6 times 10 when we wrote this down? Do you see 6 times 10 up there? Nope. Do you see 6 times 5 in our original problem? Nope. This is called the associative property. Yeah, write that down somewhere. D. Okay, what's another way to do this problem? How else could I break this up? Now, we've done the distributive property. That's the first thing you have to do. You have to, first of all, break it down, right? Because we know that 60 is the same as 6 tens, right? Or 6 times 10. We know that 50 is the same as 5 times 10. So we've done a distributive property. Now we want to use the associative property to have the parentheses talk to other numbers. And there's another thing called the commutative, which means that you can also rearrange the numbers. So if I rearrange the numbers so that I can multiply them easier, I'm doing the commutative property. If I move my parentheses to different numbers, I'm doing the associative. And if I break the numbers down, I'm doing distributive. So what would be an easy way to group those? What two numbers do I probably want to group?
What I did is 6 times 5. I just kind of like added the zeros on.
Okay, but what if we wanted to, let's say we don't want to lose any numbers, so what would we do then? If we don't, because I want to use the same exact numbers that are here. I'm just going to rearrange them.
2 times 10. And you know that's
So if I were to solve this problem now, I would have 6 times 5, which is 6 times 5? 30 times, what's 10 times 10? 20? Nope. 100. And we know that in this case, you would say 3 and then however many zeros, right? Raise your hand if you can tell me in which part I use the distributive property. In fact, I want you to come up and circle it. Let's see. I'm going to draw sticks. That's what I'm going to do. I want you to come up and circle where I did the distributive property. 23. Yeah, just circle it. Show me where I did the distributive property. Everybody make sure your eyeballs are up front. Think about no. You think that one? What is one way to write 60? What's another way to write it? Okay, you could write it 6 times 10. And what's another way to write 50?
5 times 10.
Okay, what's another way to do this problem? How else could I break this up? Now, we've done the distributive property. That's the first thing you have to do. You have to, first of all, break it down, right? Because we know that 60 is the same as 6 tens, right? Or 6 times 10. We know that 50 is the same as 5 times 10. So we've done a distributive property. Now, we want to use the associative property to have the parentheses talk to other numbers. And there's another thing called the commutative, which means that you can also rearrange the numbers. So if I rearrange the numbers so that I can multiply them easier, I'm doing the commutative property. If I move my parentheses to different numbers, I'm doing the associative. And if I break the numbers down, I'm doing distributive. So what would be an easy way to group those? What two numbers do I probably want to group?
What I did is 6 times 5. I just kind of like added the zeros on.
Okay, but what if we wanted to, let's say we don't want to lose any numbers, so what would we do then? If we don't, because I want to use the same exact numbers that are here. I'm just going to rearrange them.
2 times 10. And now that's
So if I were to solve this problem now, I would have 6 times 5, which is 6 times 5? 30 times, what's 10 times 10? 20? Nope. 100. And we know that in this case, you would say 3 and then however many zeros, right? Raise your hand if you can tell me in which part I use the distributive property. In fact, I want you to come up and circle it. Let's see, I'm going to draw sticks. That's what I'm going to do. I want you to come up and circle where I did the distributive property. 23. Yeah, just circle it. Show me where I did the distributive property. Everybody make sure your eyeballs are up front. Think about, no. You think that one? Number 13, what do you think? Where do you think I started using the distributive property? If I had a big stack of papers and I distribute it to everybody in the class, my stack becomes smaller and every single person has their own, right? So where did I break it down? I'll get the arrow down here too. There we go. Perfect. Because when I did the distributive property, I took 60 and turned it into 6 times 10 and 55 times 10. Let's see, who can circle? Or just come and explain to me how I use the associative property. 14, do you think you can? Tell me how I use the associative property in this problem. Perfect. Good job. Man, you're doing a good job listening. So in this problem right here, I did 6 times 10 in parentheses, but then if you go down below, I have 6 times 5 in parentheses, and then 5 times 10 and 10 times 10. Commutative is when you rearrange the numbers. Number 6, you need to be looking up here at the board, not facing backwards, or you're not going to know what to do. It'll be a sad day. Okay. We're going to do one more. I'm going to explain our assignment. I want you to find the product of this number. You can talk to your partner. Using any method, distributive, associative, commutative, which one would be the best? Okay, it's just about base or blue jay time, so let's go ahead and talk about this. Raise your hand if you found that using the distributive property was the best way to do this. I would say so myself. Let's look at this. If I use the distributive property, I would start with, well, what place is the 4 in? The hundreds. How many hundreds do I have? 4. So I would have 400 times 8. And then what would my next number be? 50 times 8. And my next number, what do you think? One times 8. What's 400 times 8? 32. 100. Or you just say 4 times 8 is 32, and there's 2 zeros. Add the 2 zeros. 5 times 8 is 40. Add a 0. And 1 times 8. Now, if I were doing this on a place value chart, which would be nice if you guys would use that, I could line up my numbers on my place value chart. And then add them together. That makes it a lot easier, doesn't it? Any questions about this one so far? I know you have a lot of questions when you do your work, because as I'm looking around, I see some people flipping markers and looking at the floor or looking at this or that. You make sure you're paying close attention, because it's going to eventually catch up, which is not good. So you look at the number, which place it's in, and you can use a distributive. Now, a lot of times I've seen distributive like this. Raise your hand if you've ever seen a problem like that before. Well, see, now you know how to solve problems like that, don't you? Because it's exactly what we just did. 800 plus 400 plus